Hello, let's solve the differential equation given double dash plus y dash sin h square y equal to y dash square into cot hy, right? We need to find a general solution, right? So let's start solving. As y double dash is d square y by dx square plus sin h square y into dy by dx equal to dy by dx whole square into cot hy. Fine. Now let's make some substitution. So let's consider p as dv by dx. Fine. Now if you differentiate it again, dp by dx becomes d square y by dx square. Fine. Now this dp by dx can be written as dp by dy into dy by dx, right, is equal to d square y by dx square. As you can see, we have considered dy by dx as p, so this will be p into dp by dy is equal to d square y by dx square. Okay. Now, so let's substitute in the given equation, which is the first term is d square y by dx square, which is in terms of p dp by dy plus sin h square y into dy by dx is p equal to dy by dx whole square, right, which is p square cot hy, right? One of the p's will get cancelled. Now this you can simplify as dp by dy minus of p cot hy equal to minus sin h square y, right? This looks like a first order differential equation of the form dy by dx plus p of x into y equal to q of x, right? There is a available integrating factor formula for this, which is integrating factor here it is equal to e power integral of, right, p of x dx, right? Here p of x is, I mean, when it compared to the general formula here, which is minus cot hy dy. So integral of this is minus of ln sin hy. This can be written as e power ln of m log a equal to log a power m, right? So this will be ln sin hy whole power minus 1, which can be written as ln cosecant hy. So which is equal to cosecant hy, right? This is the integrating factor. The integrating factor is cosecant hy. So now let's multiply this to the differential equation, this, which is cosecant hy into dp by dy minus p cosecant hy into cot hy equal to cosecant hy, sorry, there is minus sin h square y. Now as you can see, the left hand side can be written as d by dy of p into cosecant hy, right? This can be cosecant hy can be written as 1 by sin hy, then one of the sin hy's will go off, then you are left with minus sin hy, right? Now let's integrate it, then you will get this is as If you integrate this, uh, d of p cosecant hy equal to minus of integral sin hy d. So this will be p cosecant hy, which is converted as in the denominator as sin hy, is equal to minus of sin hy integration is cos hy. Let's suppose there is some constant a, fine, constant a which belongs to R. Now, as you can see, um, just write it as a minus cos hy, right? Fine, minus cos hy plus y. Now you need to simplify it further, right? Because p is a, we have assumed it p as a dy by dx, right? P as dy by dx, which is 1 by sin hy, right, into dy by dx equal to, let's write it down properly so that you can understand well. Here it is 1 by sin hy. P is dy by dx, right? This is a minus cos hy. Fine. Now this will become dy by sin hy into a minus cos hy. Right? Let's bring the term on the right hand side to the left hand side. This is equal to dx. Fine. Now let's try to integrate these terms. Right? This term on the right hand side becomes x plus, let some b, which is constant, integration constant. Right? Now, as you can see in the denominator, there is a minus cos hy and sin hy. Let's try to bring in only one term. I mean to say only in one form, which is cos hy. So it will be easier if it's sin hy turns into cos hy, right? So let's multiply it with sin hy dy by sin hy, right? Then becomes sin h square y, right, into a minus cos hy. Fine. This will get simplified further to integral sin hy dy by sin h square y can be written as cos h square y, right, minus 1. This can be written as cos h square y minus 1 into a minus cos hy is equal to x plus b. Fine. Now we need to make again some substitutions. As you can see, these are hyperbolic functions. Let's consider u equal to cos hy. Fine. Now this du is cos hy, differentiation is sin hy dy. Fine. Now the integration becomes sin hy dy is du, fine, by cos h square y minus 1 is cos h square minus 1 u square minus 1, which can be written as u plus 1 into u minus 1 into a minus cos hy, which is minus u equal to x plus p. Fine. Now, as you can see, you know this simple tricks which we apply here. As the denominator is u plus 1 into u minus 1 into a minus u du equal to x plus b. Right? As you can see, there is u plus 1 into u minus 1. So the simple trick will be u plus 1 minus of u minus 1. Fine. Because you can see u will get cancelled here and 1 minus of minus 1, which will get 2. So to compensate the 2 factor, let's divide it with 2. Fine. Now let's separate these terms, right? This becomes 1 by 2 into the first term becomes u plus 1 will get cancelled and you are left with 1 by u minus 1 into a minus u du, and the second term will be minus half into u minus 1 will get cancelled and you are left with 1 by u plus 1 into a minus u du is equal to x plus b, right? Now let's simplify it further using same trick. As you can see, it's 1 by 2 into integral. The denominator part is u minus 1 into a minus u. As you know that capital A is some constant which is was integration constant. So let's do one thing here. You can add a minus u plus of u minus 1. Fine. Now you can see plus u minus u will get cancelled and you are left with a minus 1. So divide it a minus 1. So this will be simplified further, right? Similarly, here this will be minus 1 by 2 into integral. This part will be denominator will be the same, a minus u du equal to x plus b. Now, as you can see here, we are going to do the same trick, a minus u plus u plus 1. Now, u plus u minus u will get cancelled and you will get extra term of a plus 1 in the numerator, which is a constant. So, divide it with a plus 1. Fine. Now, let's simplify this. Simplify it further. The first term will be 1 by 2 into a minus 1 into, as you can see, a minus u will get cancelled and you are left with 1 by u minus 1 du plus 1 by 2 into a minus 1. In this second term, u minus 1 will get cancelled and you are left with integral 1 by a minus u du. Fine. Here minus 1 by 2 into a plus 1 into a minus u will get cancelled and you are left with 1 by u plus 1 du. Similarly, here this part will be 1 by 2 into a plus 1 into integral. For second term, u plus 1 will get cancelled and you are left with du by a minus u is equal to x plus b. Fine. So now you need to simplify it further. How will you proceed? Let's think. The first term here it is 1 by 2 into this is constant, right? It's not going to change. Now integral du by u minus 1 is ln of mod u minus 1, fine, plus, so I will tell you why this minus comes here. 1 by 2 into a minus 1 into this becomes ln of a minus u, right? Then you need to differentiate again this a minus u, which becomes minus. So that's why instead of plus there is a minus here, right? Then the third term is 1 by 2 into a plus 1 into ln of mod u plus 1. Right? Similarly, this case here becomes, because a minus u there, this becomes plus term 1 by 2 into a plus 1 into ln of a minus u. Right? There is, because there is a minus u there, if you differentiate it again, it will come minus 1 factor. So that's why minus become plus. Here it's become plus. Fine. Is equal to x plus b. Fine. Now let's simplify it further. This first term ln of mod u minus 1 by 2 into a minus 1 minus of ln of the start term u plus 1 mod u plus 1 by 2 into a plus 1, right? Then we are left with second and fourth term, which is, as you can see, there is ln of a minus u and ln of a minus u. You can take it as a common. ln of, sorry, I mean ln, sorry, it becomes somewhat slow. ln of a minus u, fine, ln of a minus u into 1 by 2 into a plus 1 minus 1 by 2 into a minus 1, fine, which is equal to x plus b. Now let's simplify it further. This will be 1 by 2 into a minus 1. As you can see, we have considered u equal to cos hy, right? Then this is ln of mod cos hy minus 1 minus 1 by 2 into a plus 1 into ln of mod cos hy plus 1. Fine. Now this next term is plus ln of a minus cos hy into this term will be, as you can see, this will be 2a minus 2 minus 2a minus 2, right, which will be the numerator minus 4 by 4 into a square minus 1 is equal to x plus b. Fine. Now this 4 will get cancelled. Now this simplification will be 1 by 2 into a minus 1 into ln of, you can do one thing here to simplify it further. You can add, sorry, you can multiply and divide with cos hy plus 1, right? If you multiply and divide with cos hy plus 1, then this becomes cos h²y minus 1 by cos hy plus 1. Fine. This will minus 1 by 2 into a plus 1 into ln of mod cos hy plus 1, right? Then this is minus 1 by a square minus 1 into ln of a minus cos hy is equal to x plus b. Fine. Now you need to proceed further. This is 1 by 2 into a minus 1, as ln a by b is ln a minus ln b, ln of cos h²y minus 1, which is sin h²y, then which can be written as 2 into ln of sin hy minus ln of cos hy plus 1. Fine. Then this next term is minus 1 by 2 into a plus 1 into ln of mod cos hy plus 1 minus ln of a minus cos hy by a square minus 1 equal to x plus b. Fine. Now this will be Let's simplify it further. As you can see in the first term, this will be 2 will get cancelled, and we are left with ln of sin hy by a minus 1, fine, minus, now can you see, as you can see, there is cos hy plus 1 terms, right? These two terms are similar. So let's take some common and simplify it. Ln of cos hy plus 1. So you are left with uh, 1 by 2a minus 1 by 2 into a minus 1, right? Plus 1 by 2 into a plus 1. Fine. These terms are gone, and you are left with minus of ln a minus cos hy by a square minus 1 equal to x plus b. Fine. Now this will become ln of sin hy by a minus 1. Fine. This will be minus ln of this becomes cos hy plus 1 into, if you, this will become 2a plus 1, this will become 2a plus 1 plus 2a minus 1, plus 2 minus 2 will get cancelled, and you are left with 4a, right? You are left with 4a by this 4 into a plus 1 into a minus 1, which is a square minus 1 minus ln of a minus cos hy by a square minus 1 is equal to x plus b. Fine. Now you can do some simplification, which is 4 get cancelled, right? So this becomes, now as you can see in the denominator, the second and third term contains a square minus 1. So let's write a square minus 1 for the first term also. You can do it, but just multiplying and dividing with a plus 1. So this will become a plus 1 into ln of sin hy by a square minus 1. Fine. The second terms are a by a square minus 1 into ln of 1 plus cos hy minus ln of a minus cos hy by a square minus 1 is equal to x plus b. Fine. Now this becomes, we can do the LCM. This becomes a plus 1 into ln sin hy minus a ln of 1 plus cos hy minus ln of a minus cos hy is equal to x plus b into a square minus 1. Fine. Now this can be written as m log a can be written as log a power m, right, which can be ln sin h whole power a plus 1 into y minus, right, ln of 1 plus cos hy whole power a. Fine. This is ln of a minus cos hy as it is equal to a square minus 1 into x plus b. This is ln a minus b, which can be written as ln of a by b. So this becomes ln of sin h whole power a plus 1 into y by 1 plus cos hy whole power a into a minus cos hy. which is equal to a square minus 1 into x plus b. Fine. Now this can be written as sin h a plus 1 into y by a minus cos hy into 1 plus cos hy whole power a is equal to e power a square minus 1 into x plus b. Right? This can be you can split it as e power a square minus 1 into x into e power b into a square minus 1. Fine. Because this is a and b are constant, this term you can take it as a c. Then this becomes c into e power of a square minus 1 into x. Fine. Now you can see that sin hy can be written as 2 sin h y by 2 into cos h y by 2, as there is sin hy whole power a plus 1, so everything will get power of a plus 1. Fine. By now e minus cos hy 1 plus cos hy can be written as 2 cos h square y by 2 is equal to c into e power of a square minus 1 into x. Fine. Now this can be written as 2 cos square hy by 2, right? Yeah, fine. Did I miss something? One, oh, sorry, there is a, right? 1 plus cos hy whole power a, then this becomes 2a, right? So this can be written as 2 power a plus 1 into sin h a plus 1 y by 2 into cos h a plus 1 into y by 2 by this term. This is 2, right? So write constant out first. 2 power this will be 2 power a. Fine. As you can see, 1 plus cos hy equal to 2 cos h square, right? 1 plus cos hy equal to 2 cos h square y whole power a, which is 2 power a into cos hy whole power 2a. Fine. This is a 2a into cos h 2a y by 2 into a minus cos hy is equal to c into e power of a square minus 1 into x. Fine. Now as you can see, this 2 power a will get cancelled and you are left with 2, right? This is 2, and how can you write this? Sin h y by 2 whole power a plus 1 be can written as sin h y by 2 into sin h y by 2 whole power a. Fine. This can be written as sin h y by 2 cos h of y by 2. I will explain it. Tan h per whole y by 2 by a minus cos hy is equal to c into e power of a square minus 1 into x. Right? As you can see here, there is cos h a plus 1 by 2, right? This cos h power 2a y by 2, when it goes in the numerator, it becomes minus 2a. So a plus 1 minus 2a, which becomes a plus 1 minus 2a minus a plus 1, right? When it comes to the denominator again, it will become 1 minus a, right? Then there is one more sin h y by 2 a, right? Then it becomes tan h of y by 2. Fine. So finally our solution becomes 2 sin h y by 2 cos h y by 2 can be written as sin hy. Fine. Then this is tan h whole power a y by 2 by a minus cos hy is equal to c into e power of a square minus 1 into x. Right? So this is the general solution for the given differential equation.